Hi everyone, welcome back. This is Raju from Smart AI Technologies. In this video, we are going to see a project demo for food supply chain traceability system using blockchain technologies. So before moving further, here we will be discussing what is the need of it and why we need to build a blockchain technology here, and how our defined methodology is better than the existing system, because that's what we need to define our own methodology which is better than the existing. Then only you can write and you can publish any papers, and your project will be having more weightage. So before moving further, we'll check with this paper. So we are taking this paper as a base paper or a reference, you can say. So in this paper, what they are speaking about, what technology they are using. First, we'll try to understand that. So here, these people are using normal Ethereum blockchain, which is already available. Ethereum is like a platform for a blockchain, which uses Ethos as an encryption technology that is being used here. So they call it food supply chain traceability system. Okay, so they are defining this system as that, and they are using interplanetary file system IPFS for files and folder exchange. That is available in the blockchain, that is Ethereum. What they are using, it is already available. Ethereum is already available. It is a framework like stuff, and here they are trying to provide the graph food demand growth versus population, how it's increasing. Because the population is increasing, there will always be a demand for the food. And the same thing you can see, but it is with respect to the location. So how that what do you say, the percentage of the wastage of a different entities, how they are there. Okay, so those things are being displayed here. This is a data, okay, the collected data for the food. Now this is the process. So here in this proposed paper, they say what are the different units are there in this project is, one is production unit, processing unit, handling and storage unit, distribution unit, consumer unit. In our case, what are the things that we are having? Okay, that one we will discuss now. Now in our case, we have like this: farmer, processor, distributor, retailer, consumer, as well as this is the extra thing that I will be discussing with you. What is this feature and why we are integrating this, and how all these things are working together. This is the front end built for our project. We used Flash for the backend and HTML CSS for the front end. So we'll be discussing about these things in clear, and we'll be seeing the demo of it also. So before that, like that, here there are units. So how the product agriculture product is moving from one unit to another unit, the whole data should be stored safely. So maybe about production, where it is produced, who is the farmer, like from where it is coming from, all those details should be stored. Store and retrieve the data, IPFS they are using, and all these things. Okay, whatever the Ethereum they are using, there is no much control over the encryption techniques are like that from these people hand, because already everything is already predefined. So this paper is just using them. They are not defining any special technique over the encryption technique over the safety and the security of the files. And the whole system structure, you can see here how the system works: production unit, processing unit, handling and storage unit. So all the files and folders will be accessed or pushed to interplanetary file system IPFS, and the whole stuff will be now coming to Ethereum virtual machine, EVM, what they say, or smart contract. With smart contract they should access the data. And then comes distribution unit as well as consumer unit. All units must use Ethereum as well as IPFS of that Ethereum. Same thing you can see again with the time series diagram, how the data is getting exchanged. So this is all about this paper. Again and again they are trying to mention what they are using. Almost it is like Ethereum plus IPFS, interplanetary file system. Only these two they are getting used because they don't have much control over the different techniques of this part of the project. They can't control the flow of the data. They can't control the type of encryption techniques. They can't do much. They should use whatever is already available. Here there is a lot of gap. So this gap we are going to fill with our research. So what is our proposed methodology and what we are trying to do? What special we are doing in our project? We will first discuss that. So I will be better drawing and I will be showing you those details. First of all, we have these many classes. It starts from producer, that is farmer, and then goes the processor, then goes the distributor, then goes the retailer, then consumer. Consumer can validate how the product is being came from one unit to another unit. And then here this is our extra work. Check food quality. For example, if a food product is coming from A to retailer to consumer, what is the quality of that food now, for now, whether it is consumable, whether it is eligible to consume, or whether it is not. So that is the most important stuff, not only tracing the data. So with that we are adding food quality. For this we are using machine learning. So our project is even having the machine learning integrated within it, as well as the blockchain technology. So we are going one step further. So if we have so much of data traced, what we should do with the data, that's what the machine learning comes into act. So this will be blockchain plus machine learning. So this machine learning is not proposed in any of the papers that you can go through, even not in the base paper. So how the things are going, we'll see. For every unit that is there, we'll validate, maybe farmer or processor will validate with the user ID as well as the password. So first level of authentication will happen, and then now when farmer puts the detail for that product, those details should be taken. And now normally in Ethereum case, these things will be encrypted with ethers, and that will be stored in IPFS, what they say. But in our case, how we can make those details more secured is that what we are going to do is, whatever the data that we are going to get, we will hash code that. We will hash code the data. For that we are going to use SHA-512. Okay, SHA-512 or 256, it depends, whatever we can select accordingly. So SHA-512 is an hashing algorithm, or you can say a blockchain conversion algorithm. Here the whole data will get transformed. For example, a farmer is producing apple. Okay, maybe this apple details is fed from the initial state, that is farmer is feeding these details. These details will be transformed. Hashing will transform the data itself. If it is an apple, it will become XYZW something something. So hashing is the type of encryption where the whole data will transform. So that is a profit of hash coding. So once the data is being hash coded, now what we do to this data is that we will use second layer of protection here. So that is, we will use RSA algorithms. RSA algorithm with private key public key, AES algorithm, what you say, private key and public key pair. Okay, private key as well as the public key pair, we will use it. So this is not available in the paper that we are taking as a base paper. They don't have control over these technologies, they can't control what is happening within that, but we can control the things, we can make it more complex. So now the whatever the data is coming, it will be encrypted with the public key. Now here the challenge is, what if some attacker attacks, and even they can go through and they can generate public key and private keys pairs, and they can decrypt and they can access that data, they can manipulate or do anything. Now how we overcome this challenge is that whatever public key private key pairs are there, we will make sure no one can get whatever technology they use, whatever type of attacks they use, they should not get private key public key pair at all. How to make sure it happens in such a way? So here comes the most complex work. First what we do is we take an image. Let us take one human image we are taking. Any random image we will take. We will apply deep learning. Again, one more technology entered here, that is deep learning. Till now we are discussing blockchain and machine learning. Within this blockchain there is a deep learning involvement. So now one more technology and one more complex work. So now with help of deep learning, we are going to extract features of that image and we will make sequence out of it. And then what is the next technology? Sift. Okay, LSFA, what you say, it means we need to sift those values with a fixed range and fixed pattern. Double right shift or double left shift and one right shift, it means shifting the values, and even we are converting this into some other values, shifted. LSFA, what we do, and once we shift, this data is very unique. Now we use this data as a overhead to generate private key public key pair. So now you can see no one can generate this private key public key, no one can, even they can't do brute force attack also. They can't do man in middle attack, they can't do anything to access these details because they don't have this image. It is not that much easy to have image. We can use any image, any random image, you can use your face image, you can use ABCD of any image. So no one can generate private key public key, so it will become highly impossible first of all to access. Even though they come to hash code, they can't even get what that hash code is. So here this layer of protection is one of the very unique and very highly protective, so no one can access the data. So all the data, whatever different unit data are coming, all those data will be now encrypted like this. So the whole data, whatever you see, the whole data is more secure and safe. So this is our defined methodology. So our defined methodology is far better than the present existing IEEE paper that we are taking it as a base paper. So this will be one of the best blockchain technology project for your research, any final year projects. So we Smart AI technologies help researchers, students or any startups with AI, ML and data science. Even you can go to our channel and there you can see more and many videos on AI, ML and data science, computer vision, NLP, deep learning, machine learning. So there are so many videos. If you once check it, you may get some other ideas over your projects and you can implement all of them in your work. Now moving further, whatever I'm explaining you, how I implemented, first we'll see the demonstration of it. First we'll see the demo of that project. Now what we'll do is, we'll go from the farmer side. For this I am using a local database for authentication. SQL, MySQL database I'm using. Once farmer logins, he can feed the details. Farmer ID, he can feed like FT546. Product name, whether it is an apple, let us take apple itself. After that, product ID is the most important thing. This product ID will be taken throughout the process. So product ID will be very unique. Let me take A2. Location, maybe we are starting from Bangalore, and date will be like today we are pushing it. Maybe after one day it will be reaching that location. Next unit, type of form, can give anything like organic or inorganic type of agriculture. You can give anything. Form of work is done. Now comes the processor. Processor need to feed the details. Now processor base, he can feed his details. Processor ID, maybe PR42. Product name, again it will be Apple itself. Product ID, in our case it is A2. Location, now itself it is the product is in Bangalore itself. Maybe on 2 it is in Bangalore, and it will live at the 5th. Type of packing, how they done. Type of storage. Will be feeding all those details, and when you submit, the processor details will be now saved. And then comes the distributor. Now distributor also need to provide his details. Distributor ID, distributor name, maybe a company name or a person name, you can give anything. Product name is Apple. Product ID will stay same because the same product is moving from one place to another. Now it will be reaching to Mangalore. Date will be now 5th. So it may reach around 8. Now 5th to. Now type of packaging in boxes. Type of storage, cold storage. Now distributor part is done. Then comes the retailer. Now retailer ID, retailer name, product name Apple, and product ID A2. Location, now it is in Mangalore. Arrival date and this date you need to give. Type of packing, storage. So till now we came from farmer to retailer. Now what is the part of consumer? Now you can see here, till now whatever you did, you will be having QR code for that. So this is that QR code generated for the product. So now when consumer we'll click on the camera, we'll be having that A2. Okay, so now with camera, consumer need to scan that QR code. Okay. Now it opened the camera. I have a external camera attached. I will scan this QR code. Now you see the details that are being traced out. Farmer details, as well as next go to processor details, distributor data, retailer data. So all these data will be now displayed in front of the customer, and as well as even I am trying to integrate the quality of the product prediction here itself. Even I done that part. Even I will be showing you, will be giving you that part. It is automation, automatically detect the quality using all these informations. Or even you can manually upload the data like this. So here for this part we use different machine learnings. So for this we have a data set. Even I will be showing you the data set whatever we are using. So you can give what is the product name, packaging, how it is being done, trace boxes, okay, times in storage, whether it was like 10 days in the storage total. Initially what was the quality of that product, storage temperature and storage humidity, storage location, what type of location it was, warehouse or cold room, whatever it was, and how the product is being harvested, whether it is hand picked or any other ways of processing it, transportation condition, it was frozen, processing method, what type of processing method is being used, and chemical additives, what type of additives are being used. So all this information, if I get all this information, when you click for the this food quality, it will give you that particular food is not eligible for consuming. Maybe the reason may be not, if not the packaging, time and storage, it will be either using chemical additives, because they are most important, chemical additives or processing method, transportation condition. So all these things matter for the quality of the product. Even normally consumers, when you see the entire trace of the product, he may see how it came, but he can't analyze, or you can't think about the quality of the food. So in that case, this part will help. So this project is actually the combination of blockchain technology, deep learning plus machine learning. So for this we are using Python coding. For the backend we are using Flask. For the front end we are using HTML and CSS with JavaScript. Yeah, this was all about the project. Now I can show you some part of codings, how the codings are being done. So you can see here all HTML files whatever we have used, okay, all of them are there, and main file is actually app.py. So this is server side coding. You can see for everything the data will exchange, the data will be secured using encryption techniques. And we are using interconnector, we are calling some functions from external stuff. So you can see here safety detection, that is the model, the machine learning model. You can see them here. So this is the XGBoost model that we are using. We have trained it, we have built a model, we have trained a model using Jupyter notebook. All those codes we can provide to you. We have all the codes, we have done all the combinations and permutation of different technologies and techniques. And this is that base paper, whatever I shown you at the start of the video, we even can give you the base paper. And if you want this full working code to be implemented in your system, as well as if you need documentation, if you need mentorship, you can approach us, you can call us, or you can just WhatsApp us to the given number. You can check the number, okay, it is being provided below in the description. And if you are having your own ideas, if you are having your own methodologies, here you can approach us with that. We even will help you to build that, and we will help you to implement that in your system as well. As thank you for that, and we'll be see you in the next video with great project. Thank you very much. Don't forget to like and subscribe our channel. Thank you.